Don't play with it, don't be dishonest. Ay, still not understanding.
Hi guys, welcome to this video. Today we'll be looking at accommodation and pupillary mechanism. Starting with accommodation, these are changes in the shape of the lens so that a clear image forms on the retina when you're looking at objects that are distant or nearby. So here we look at the retina. Since it contains photoreceptors, they convert light stimulus into an impulse, and then the impulse is transmitted to the cerebrum for interpretation. So whether the light is coming from a distant or it's coming from a nearby object. So when it's coming from a distant object, they usually say a learner is watching a soccer match from a pavilion, etc. And when it's from a nearby object, they usually say the learner is reading a book. And because it is changes on the lens, so the lens is a biconvex structure that can either be more convex or less convex. Now when you look at accommodation, there are parts that are involved as drawn here. You have your biconvex lens, we have the suspensory ligaments, as well as the ciliary muscles. Just take note, ciliary muscles contract or relax either when you're looking at a distant object or a nearby object. So in this case, our lens is more convex. So it means that the ciliary muscles, they are going to contract so that the suspensory ligaments, they slacken. So we're going to mention there that the biconvex lens becomes more convex. The reasons why the biconvex lens becomes more convex is so that there is less tension on the lens, and therefore the refractive power of the lens is going to increase. This means that light is going to be refracted more, and then the light will bend and land onto the retina to form a clear image. This key statement that light will land onto the retina and a clear image forms is very important to mention. What we've explained here is nearby vision. So how I usually understand it is that the object is nearby. So there's less distance between the object and the eye. So the lens is creating more space for light to bend, because for you to see, the light must bend. Now with distant vision, we look at the same structures, the ciliary muscles, which must now relax so that the suspensory ligaments, they tighten or become taut, and then the lens becomes less convex, which means that there will be more tension on the lens, and the refractive power of the lens will decrease, and then light will bend less, or light will be refracted less, and the light will land onto the retina to form a clear image. This, as explained, is distant vision. So for understanding distant vision, the object is far. There is more space for it to bend before it reaches the eye. By the time it gets to the lens, it shouldn't bend more. Hence, the refractive power decreases and light will bend less. Now let's look at a past exam paper. It says here, two mechanisms of the eye are illustrated in diagram 1 and 2 below. we look at diagram 1 as well as diagram 2. Now when you look at these two diagrams, there are labels A, B, and C. For diagram 1, we can see that is the front view of the eye. So which means that we're looking at pupillary mechanism. While diagram number 2 is the side view of the eye, and then we'll look at accommodation. Now the parts that are labeled, A is the sclera, B is the lens, and part C will be the ciliary muscles. Now when I look at question 2.4.1, it has to do with diagram 1. We'll come back to that later since we are looking at accommodation. Question 2.4.2 says explain the changes that are occurring in diagram number 2. When you look at the changes, specifically the lens, it is changing from less convex to more convex. So you need to explain the why. So the lens becomes more convex to allow for nearby vision. On to the next question. It says name two structures that cause the structure B to change its shape. We know that the lens is attached to suspensory ligaments as well as the ciliary muscles. Now on to the last question. It says name the condition that would occur if structure B cannot change the direction of the arrow as shown in diagram 2. So we did note that diagram 2 is for nearby vision. So if a person is unable to change to the changes shown in diagram 2, it means they will only be able to see objects that are far, and we call that long-sightedness. So we're done with this question. We can move on to the next one. It says here the diagram below shows internal structures of the eye, and we can see A and B are labeled as well as the optic nerve. We first label part A as the ciliary muscle, and part B as the suspensory ligaments. We see that we're being shown the side view of the eye, and therefore we are going to look at accommodation. For the first question, we've already labeled part A and part B. On to the next question. AC 2.2.2 and 2.2.3 are not relevant to accommodation, so we'll skip that and go to 2.2.4. It says describe how structures A and B enable the ability to focus on objects that are further than 6 meters away. So that would be distant vision. We did mention that when the object is far, light shouldn't bend even more when it gets to the lens. So it means that the lens is less convex. Which means that the suspensory ligaments will become taut and the ciliary muscles will relax. So we're going to write that down. Ciliary muscles will relax. Then suspensory ligaments become taut. The lens will become less convex. This will decrease the refractive power of the lens, and then the light will then become less convex and focus onto the retina to form a clear image. So we can move on to the next part, which is pupillary mechanism. These are changes in the size of the pupil. This is to control the amount of light entering the eye. So here we look at the size of the pupil. It is controlled by the iris, and the iris contains muscles. Usually with pupillary mechanism, we look at the front view of the eye so that we can see the iris and the pupil. So here we have the circular muscles of the iris. They are the outer circles. And then there will be radius lines, which we call the radial muscles of the iris. And lastly, the pupil. Now we start analyzing what's happening to the muscles, starting with the circular muscles. They relax so that the radial muscles contract, and then the pupil will become wider so that more light enters the eye. This is during dim light. Now with bright lights, I've already drawn the diagram. We focus on the same circular muscles, the radial muscles, and the size of the pupil. So circular muscles in this case will contract so that the radial muscles relax and the pupil will become smaller. Then less light will enter the eye. All this is happening during bright light. Now, let's summarize it for exam purposes. During dim light conditions in pupillary mechanism, we know that this is probably in a dark room, or you close your eyes. What are the changes that are taking place? So in the exam, you will mention that the circular muscles of the iris relax, the radial muscles of the iris contract, the pupil becomes wider or it dilates, more light will enter the eye. Now in dim light conditions, maybe you shine a torch into the eye. You mention as well that the circular muscles of the iris contract, the radial muscles of the iris relax, the pupil becomes smaller or it constricts, and less light enters the eye. It is important to mention all of these parts that are underlined. Now we move on to the next exam question. It says 2 mechanisms of the eye are illustrated in diagram 1 and diagram 2. This is the question we're coming back to for diagram 1. We're expected to name and describe the process that occurs in diagram 1. We can see here we have the front view of the eye, and that is pupillary mechanism. Now looking at the pupil in diagram 1, it becomes smaller, and that is controlled by the iris, specifically muscles of the iris. These are radial and circular muscles. So when you look at the 2 eyes, the first one would be dim light, and then the second one we can see that's bright light. So the question wants us to name and describe the process. We've already named it as pupillary mechanism. And by the way, this is a compulsory mark since it's in the question. It means the description will be marked out of 4. So you describe the changes that are taking place in bright light, That is the radial muscles of the iris. So it's important to mention that these muscles are of the iris. They are going to relax so that circular muscles of the iris, they contract, and then the size of the pupil will become smaller. Or you can mention that it constricts, and then less light will enter the eye. Now there are only 4 points here, so 1 mark for each point. Now let's look at another question. It says the diagram below represents pupillary mechanism. We have diagram A and B, point X and Y. X becomes the pupil and Y the iris. Obviously, this is the front view of the eye. We're looking at pupillary mechanism. The conditions are bright light and dim light. We've already answered the first question when analyzing the diagram. Part X is the pupil and part Y is the iris. For 322, it says explain why pupillary mechanism is considered to be reflex action. I'm assuming we need to define reflex action in relation to pupillary mechanism. We know that reflex action is a quick and automatic response to a stimulus, and in this case it will be a quick and automatic response to light. This is a 3-mark question, so that's how it's allocated. The next question would be 323. You name 2 effector muscles that are involved in pupillary mechanism. We know that the iris has muscles, which are radial muscle and circular muscle. Now the last question, 324, it says explain significance of the change in diameter of part X from diagram A to diagram B. So we'll start by mentioning that the pupil is dilating, or it becomes wider. This is so that more light enters the eye during dim light conditions. Now you must mention that to improve vision. This is a 4-mark question. As you can see, we mentioned that the pupil dilates so that more light enters the eye. This is during dim light conditions to improve vision. To get the 4 marks, you must mention the cause and the effect. So the first part will be the cause, and then the last 2 marks go to the effect. Now we look at the last question. It says the diagrams below show the conditions of the eye for different light intensities when viewing the same object. Here we're looking at light and we're given the front view of the eye, meaning that's pupillary mechanism. And they have labeled A, B, and C. We're looking at diagram 1, 2, and diagram 3. So to label part A, that would be our sclera, and then part B, the iris, and then part C is our pupil. We check diagram 1, looks like it's normal conditions. Diagram number 2 would be bright light, and diagram 3 is dim light. Now also take note that pupillary mechanism is controlled by the iris, and the muscles involved here are circular muscles and radial muscles. So for the first question, you give letter and name of the part that contains muscle. We know that part B, the iris. And the next question is made of tough fibrous tissue, and that would be A, the sclera. Going on to 142, which diagram 1, 2, or 3 represents the eye of a person in a very bright area. We've identified that as diagram 2. Next, where rods are stimulated the most, that would be diagram 3, since the pupil is wider. Now, in the last question, we want the muscles that are contracted in diagram number 2. We can see that the pupil is smaller, which means that the radial muscles relax so that the circular muscles contract. In the last question, we want muscles that are relaxed. We know that the pupil is wider. It means that the radial muscles contract so that the circular muscles relax. And that's all for this video. Bye.